Hello, everybody. This is Professor Jason Kim. Today's lesson is about Chapter 5.3, Introduction to Polynomials. Okay. Um, to learn the polynomial, you have to know something called terms. Terms are the either number or product of numbers and algebraic factors. That's what we call terms. So like 5 is a term, x squared, negative 40ab, 2/3 x squared y, xy over 4, negative 5x over 3. They are all terms. So polynomials consist with the terms. So when you have x squared minus 2x plus 3, let's say you have this polynomials, then each one of them become a terms. So that end up with the 3 terms. So usually terms are associated with or composed with subtraction or addition operator. So that's what terms are. Okay. And when you have a term, you have to know something called numerical coefficients. Numerical coefficient is the number factor of a term. So when you have 5x, numerical 5y rather, numerical coefficient of 5y is 5. Numerical coefficient of 2x is 2, so number portion only. Numerical coefficient of 2/3 ab squared is 2/3. Also, numerical coefficient of negative 3a would be negative 3. So numerical coefficient contain the sign number as well. Now, polynomial. Definition of polynomial is the sum of one or more than one term with the whole number exponents. So in here, so it's in other words, they are like composition or addition or subtraction of terms. That's the polynomials. But one thing you have to watch out for the polynomial is variable cannot be in the denominator. That's the most important one. So for example, these terms are connected by plus or minus operator. So 2x squared plus 5x plus 1 is polynomials. But you cannot have x in a denominator, so 5x plus 2 over 5 plus 2 over y, that's not a polynomial because you have an x in the bottom. Okay, so that's the only restriction of polynomial as of now. Now then, what kind of polynomials out there? There is something called monomial. As you know, mo means one, so one term polynomial, like negative 2a squared b is monomial. Binomial, bi means two, so it's a two-term polynomial. Usually consists with addition operator or subtraction operator. So when you have negative 2 plus a squared, that's binomial. Or in another case, like x squared minus 1 is binomial because you have two terms and separate by plus or minus operator. Trinomial, tri means three, so three-term polynomials we call trinomial. So negative 2 plus a squared plus b, we call this as a trinomials. Polynomial is no special name given to more than three terms. Well, actually they are, but in our level, we only differentiate the monomial, binomial, trinomials. All of this we call polynomials. So polynomials are generic terms for one or more terms consist with the addition or subtraction operator. Now, when you have a times b or 2ab, what is this? This is consists with the 2 times a times b, but no plus or minus operator. So this whole thing become monomial one term. Okay. But when you have 2 plus ab, because you are connecting with addition or subtraction operator with a 2 and ab, it become two terms, which is binomial. But when you have 2 plus a minus b, they consist with addition operator and subtraction operator. Then you have individual three terms, 2 as one term, a as term, and b as a term. So it has three terms, and we call this one as trinomial. Okay. So again, the polynomial is the terms are connected with a plus or minus operator. Okay. Now there is something called degree of the polynomials. Degree of polynomial is highest power of any one term or largest sum of the power in any single term. We call that one as a degree of polynomial. So when you have polynomial like this, so you have four terms, 5x fifth plus 2x third minus 4x squared plus 1. Degree of polynomial will be 5 because the highest power was fifth. So that become a degree of polynomial. Next example, you have 2 plus a minus 3a squared plus 4a third. Now, among these polynomials, what is the highest power? Third, right? So degree is 3. How about number 3? How about negative 5x? Well, negative 5x is same as negative 5x to the first power, because when there is no power, it's always one power. So degree of this polynomial become 1, because no power means one power. Number 4. How about 2? 2 is same as 2 times x to 0 power, because anything to the 0 power is 1. Because 2 means like 2 times 1. They are same values. So degree of this 2 will be 0, because the degree is usually the highest power of the variable, the letter part. Since 2 does not have x, you can create a variable, so you can create x to the 0 power or a to the 0 power, anything to 0 power. So degree that the term that do not have any letter is always degree of 0. Okay. Now, but when you have like number 5, 2x third y minus 5x squared y fourth, when you have terms more than one variable, let's say it's a square, then degree of first term, degree of the polynomial for the first term is 3 plus 2, which is the powers 5, and degree of variables on second term is 2 and 4, so 2 plus 4, so that makes 6, and then you choose the highest one. So degree of this particular binomial, because you have two terms, is 6, because that's the 6 is higher than 5, so you choose the 6. Now in number 6, degree of this polynomial, the first term, degree of the first term is a has no power, so it's 1. B has power of 2, so it's 2. C has a 3. So 1 plus 2 plus 3 will be 6. So degree of the first term is 6. Notice that A is the same as a to the 1 power. So that's why you got 1 here. Okay. Now degree of the second term would be 5 plus 4 plus 3. So adding them together, 9 plus 3 is 12. So 12 is bigger than 6. So degree of this particular polynomial in number 6 is 12. Okay, so everybody understand the degree of polynomial? Okay. Now, next topic. When you write a polynomial, the general consensus of that is you always write in descending degree of the variable. So when you have 2 plus x third minus x squared, you don't leave like that. You rewrite this into x third first minus, let's say it's negative 2 plus x squared minus x squared. So x squared is the highest degree, so you write that first, and minus x squared and negative 2. So you rewrite polynomial in highest to lowest power or degree. Okay? So that's the general consensus. Now, evaluating the polynomial, evaluating means getting an answer, getting a value. So if you have x third minus 3x squared minus 2x plus 5, and they want to evaluate when x equals 3. So what that means is they want to replace x as 3. So instead of x, you put parentheses. And 3 times instead of x, you put parentheses squared minus 2 times of x plus 5. So always good idea that you just have extra step of writing parentheses, replacing x as parentheses. And then you put the number there. In this case, x is 3. And then this whole thing become a order of operation. So 3 to the third is 3 times 3 times 3. So it becomes 27. Minus 3 times x squared means 3 times 3, which is 9. Minus 2 times 3 is 6, plus 5. So 3 times 3 is 27, right? So 27 minus 27, which becomes a 0. Minus 6 plus 5 become negative 1, because bigger number has negative, so it's negative 1. So final answer become 0 plus negative 1, negative 1. So that's how you get this. Okay. Now what if x equals negative 3? So again, you substitute each x as negative 3, and you do the order of operations. So now you have to be careful because you are dealing with the negative values. So first term, negative 3 times negative 3 times negative 3. You have a 3 negative, so it's a negative. And 3 times 3 times 3 is 27. So first one becomes negative 27. Second one, you have to be careful because you have 3 parentheses open negative 3 square. So that means by doing the order of operation, you have to do the power first. So that's same as minus 3 times positive 9, because negative 3 times negative 3 become positive 9. Minus. So you have a minus operator here, you have a minus operator here. So it's minus here and minus there. 2 times negative 3 is negative 6, because 2 is positive and multiplied by negative is negative, plus 5. So you end up with negative 27 minus 27, because 3 times 7, not 3 times 9 is 27, minus negative. When there are minus and negative together, they become plus 6, plus 5. Negative 27 minus 27, if you do keep change, that become negative 54. And you add that with a positive 6, so it become negative 48. And negative 48 plus 5 become negative 43. Okay, so this particular operation require sign number operations. Okay, just in case that some of you forgot sign number operation. If you have a negative 27 minus 27, if you do the keep change, you keep this, change minus to plus, change 27 to 27 means positive 27, so negative 27. So when you have addition of two negative, same sign you add, so it's a negative of 27 plus 27, you end up with negative 54. So next operation, when you have negative 54 plus 6, since it's addition, you don't have to do keep change. Keep change is only for when you have subtraction. So this one you don't have to do keep change. You just apply the addition rule, same sign or a different sign. Right now you have a different sign because 6 is positive 6. And you follow bigger number, bigger absolute value sign, which is negative. So negative with a different sign. So you subtract 54 minus 6. So you end up with negative of inside is 48, negative 48. So that was process 1, and this is process 2. Now process 3. Process 3 is negative 48 plus 5. Again, you have addition, so you don't have to do the keep change. You just do the addition rule. Addition rule, different sign you subtract and follow bigger absolute value sign. So bigger absolute value 48 is negative, and you get a difference. So it become negative 43. So that's how you got that. So you have to be very careful when you have sign number operations. Okay. Now, section 5.4 is addition and subtraction of polynomials. Now, in here, many times we have to be careful about removing parentheses. When you remove the parentheses, usually parentheses are there to group them. So, but sometimes you have to combine the like term, so you have to remove the parentheses if you have more than one term there. But like example 1, addition of a polynomial. If you have an addition between the parentheses, then that's very easy. All you have to do is just remove the parentheses and write as it is. So 2x plus 3, you just write 2x plus 3. Plus 3x plus 4, you just write 3x plus 4. So when you have an addition between the parentheses, all you have to do is just remove the parentheses and then combine the like term. So 2x and 3x is like term, so you combine them. And 3 and 4 is a like term, you combine them. And then you simplify them. 2x plus 5x, 3x is 5x, plus 3 plus 4 become 7. So you end up with a 5x plus 7. So addition of polynomial with a parenthesis is pretty simple. Again, another example, when you have a 3x squared plus 5x plus 6x minus 7 in parentheses. sometimes we call parentheses as a quantity of. So if I reread this, quantity of 3x squared plus 5x plus quantity of 6x minus 7, you just write as it is when you have addition of parentheses. And then you combine the like term. So you have 3x squared, you have a 5x and 6x, so you add, and minus 7. So that becomes 11x. So you end up with 3x squared plus 11x minus 7. Now, the next example, you have negative 7 plus 4x minus 2x squared. Well, again, as I said before, when you have mixture of polynomial, you always rewrite them in descending order. So highest power first, and then second highest power of the letter, and then the number is always the last. So you rearrange them, and you rearrange this, okay? And because this is addition again, you just remove the parentheses. And then you combine the like terms, negative 2x squared with a 7x squared. So you put them in together. Next, 4x with a negative 2x, you put them together. And last, negative 7 with a negative 5, you put them together. And then you combine the like term. The reason why you have to put them together is if they are like term, you have to group them and simplify them. So negative 2x plus 7x squared, negative 2x squared plus 7x squared become 5x squared, because negative 2 plus 7 is positive 5. Because you have a different sign, so you subtract, but bigger number has positive, bigger absolute value has a positive, so you end up with a positive 5, so you end up with 5x squared. And 4x minus 2x is 2x. Negative 7 minus 5 is a subtraction. So whenever you have a subtraction, you could do keep, change. So negative 7 plus negative 5. Because you keep this, you change the operator, minus the plus. You change the 5 into negative 5. So you do keep, change only because they are subtraction. So any subtraction of sign number operation, you have to do keep, change, and then you apply addition rule. So according to the addition rule, because now it's addition, you apply the addition rule. Same sign you add and keep the bigger absolute value, sign of the bigger absolute value. So negative with a 7 plus 5. So you end up with negative 12. So you got negative 12 here. Okay. Now the problem is a subtraction of polynomial. Example 2. Again, whenever you have a subtraction, what do you do? In sign number operation, you do the keep, change to convert the subtraction into addition, and then you apply addition rule. So that's what exactly I'm going to do. When you have 2x plus 3 minus 3x plus 4. Okay. So when you have this, you keep this, you change minus 2 plus, and you change everything inside of the parentheses into the other sign or the other operator. So again, that becomes 2x plus 3. You keep this, and you change the minus 2 plus, because you're doing keep, change. And then you have to change, keep, change. You have to change the second term. 3x become negative 3x, plus 4 become minus 4. That's what you change it. So if you have a positive sign alone, like 3x, it becomes negative 3x. Operator plus become minus, and 4. Okay. So you keep, change. So you only change this and this. And then you combine the like term. So you have a 2x plus negative 3x as like term, and plus 3 minus 3 plus negative 4. Because you have 3 with a negative 4. 3 plus negative 4. So that become negative 1x, and 3 plus negative 4, again, 3 plus negative 4 become negative 1. Because bigger number has a negative. So negative and different sign, subtract. So you end up with negative 1 minus 1. Now again, another example, 3x squared plus 5x. Again, you have a minus and second term. So you have to do keep change. So you keep this, change minus to plus, change 6x to negative 6x, minus 7 to plus 7. And then you combine the like terms. So 3x squared alone, 5x with a negative 6x here, combine them, and plus 7. So 5x plus negative 6x is negative 1x or negative x, because bigger number 5 and 6, bigger absolute value is 6, has a negative sign only. So you end up with this. When you have a plus negative, you can change it to minus. So you end up with 3x squared minus x plus 7. Now, again, if you look at number 6, you have to rearrange in descending order first. So negative x squared minus 4x minus 7 minus, you rearrange descending order again, 7x squared minus 2x minus 5. Because you have a subtraction, you have to do keep change. When you do that, you keep the first one, change minus to plus, and 7x squared become negative 7x squared, minus 2x become plus 2x, minus 5 become plus 5. And then you get rid of, I rewrite this whole thing again by get rid of parentheses and combine the like term, highest one first. So negative 2x squared with a negative 7x squared, you group them because they are like term. 4x with a 2x, you write them here as a group them, and negative 7 with a plus negative plus 5, you group them. So negative 2x squared plus negative 7, you have a like term, so you add them and keep the sign of the bigger absolute value, so it becomes negative 9x squared. 4x plus 2x is 6x. Negative 7 plus 5, you know it has to be negative, right? It's a bigger number, has a negative. So negative 2. Okay, so that becomes your final answer again. So it's a little complicated, but you can handle it as long as you know keep change for every time you have a subtraction. It just have more steps. The next topic is you have to know some word expression of in wording, something called subtraction. When you have a subtract from B, we learned this one in chapter 1. You always write after from first when there is a from. So that expression become B first, actually. B, subtract means minus, and A. So you actually subtract means minus, but you always write after from first. So B minus A instead of A minus B. So in here, if you see subtract 2x minus 3 from 5x minus 4, you write 5x minus 4 first and subtract. and then 2x minus 3 with a parenthesis. It's always good to write a parenthesis showing that that's one group. And then after that, it becomes just regular subtraction of sign number operation. So you do keep, change, change. So you keep the first one, change minus to plus, and you change 2x minus 3 as 2x as a negative 3, negative 2x, minus 3 as plus positive 3. Okay? And then you have like terms, 5x and negative 2x, you group them. Negative 4 and positive 3, you group them. And then you do combine the each group. So 5x minus 2x become 3x. Negative 4 plus 3 become negative 1. So you can rewrite this plus negative as minus. So 3x minus 1 would be the answer. Okay. Now how about subtract negative 2x plus 3 from negative 6x plus 9. So here is a from. So you rewrite negative 6x plus 9 first with a parenthesis. Subtract means minus. And then you do negative 2x plus 3. So since you have a minus, you have to do keep, change, KCC sometimes. So negative 6x plus 9, minus become plus. Change everything in here. So negative 2x become positive 2x. Plus 3 become minus 3. And then you combine the like term. So negative 3x plus 2x and 9 plus 9 minus negative 3. So that end up with negative 4x plus 6. So that becomes your final answer, which is this. Okay. You can always pause the video if I go too fast. I know I'm I'm fast, but you can always read many times. Okay. Now, number 5, subtract 2x squared minus 3x plus 4 from this again, 5x squared minus 6x minus 7. So you rewrite this expression as 5x squared minus 6x minus 7 minus 2x squared minus 3x plus 4. Okay, because you have to write whatever after from, you write it first. Okay, minus, subtraction means minus, and then second one. Because you have a minus, you have to do keep, change. First one do not change. Minus become plus. 2x squared become negative 2x squared. Plus negative 3x become positive 3x. 4 become plus negative 4. And then you combine the like terms, 5x squared with negative 2x squared, 6x with 3x, and negative 7 with negative 4. And then if you simplify each group of like terms, 5x squared minus 2x squared become 3x squared. Negative 6x plus 3x become negative 3x. Negative 7 minus 4 become negative 11. So you end up with that. Just in case you want to know, again, negative 7 minus 4, that's same as negative 7 plus negative 4 by do keep, change. You have the same sign. Now your addition rule, according to addition rule, when you have the same sign, you add them and keep the sign of big absolute value, which is negative, the 7 plus 4. So you end up with negative 11. Okay, that's how you got that. The last example, subtract 5x squared minus 6x minus 7 from 2x squared minus 3x minus 4. So you rewrite 2x squared minus 3x plus 4 first. Subtract them with 5x squared minus 6x minus 7. Because of the minus, you have to do keep, change. If you do that, you have a 2x squared minus 3x plus 4. Minus become plus. Now change everything in here. 5x squared become negative 5x. Plus negative 6x become positive 6x. Plus negative 7 become positive 7 because you have to keep change. I forgot to put the square here. Now you combine the like terms. So 2x squared plus negative 5x squared is like term. And negative 3x with a 6x is like term. And 4 with a 7 is like term. So when you have 2x squared plus negative 5x squared become negative 2x squared plus negative 3x plus 6x is 3x. Sorry, I wrote it wrongly. It's negative 3x squared plus 11. So final answer becomes this. Now I want everybody to try exercise 1 and check with the answer key in the back. Try on your own. Okay. So that's the subtraction of polynomials. Okay. So pause the video and try on your own and double check your answer with the answer key. If you make a mistake, try again and try to look for where you made a mistake. Okay. Now, chapter 5.5 is multiplication of polynomial and special product. There are several different types of multiplication. First type is monomial multiplied by monomial. Second type is monomial multiplied by binomial. And third type is monomial by polynomial. And then fourth type is binomial by binomial. And fifth case is probably binomial multiplied by polynomial, but which is not here. But I will show you, okay, this is binomial by polynomial, but I will introduce that in later part. Okay. So in multiplication, sorry that if I make you dizzy. Okay. Let's get into multiplying monomial by monomials. Okay. So you're multiplying a 2a squared b third times 3a third b fourth. So when you multiply monomial, this is monomial because you don't have any plus or minus operator there. So it's monomial. You're multiplying this monomial by another monomial. This is another monomial because you don't have, everything is connected with a multiplication or a division. Then it's monomial. No plus or minus operator. So it's monomial multiplied by monomial. So when you multiply monomial by monomial, again, you group like terms or you group same basis. Okay. So numbers are like terms, so you rewrite 2 times 3 as group, and then you group a squared with a third because they have a same base, and then you group b third with the b fourth because you have the same base. Okay, in that way it's easier for you to combine them. So 2 times 3 is 6. When you multiply, when they are next to each other without no sign, it's always a multiplication. When you multiply same base, multiply means product, same base. So product rule kick in. So a squared times a third is a 2 plus 3, which end up with a to the fifth. And b third multiplied by b fourth is, again, the product rule kick in. So you add exponents, so you end up with b to the 7. So final answer become 6 a fifth b 7, like I do have here. How about negative 3x squared y times 5x squared y fifth? Again, you group number first, group the same base second, and then group y basis third. So negative 3 times 5 become negative 15, because when you multiply side number, you count how many negative you have, and you just multiply each value. Now x squared times x squared become x 2 plus 2, which is 4. Now y times y fifth, y means y to the 1, so 1 and 5 makes 6. Okay, again, no power means 1 power. Okay, so you end up with that. So monomial multiplied by monomial is quite easy. All you have to do is combine the like term or combine the same basis, and you apply the product rules. How about multiplying monomial by binomial? So for example, you have a squared multiplied by 2x plus 3. So whenever you have addition or subtraction inside a parenthesis and there are something outside, you're supposed to distribute them. You multiply a squared with 2a plus you do a squared with 3. Okay, so you have, we call this one as distribution. You have to distribute them as long as you have a plus or a minus inside the parenthesis and there is something outside, value outside. So that become a squared with 2a plus a squared with 3. So a squared with 2a become 2a third, and a squared with 3 become 3a squared. So that's how you get this answer. Next one, monomial times binomial again. So 2p you distribute with that, and because you have plus, you write plus 2p with a 4q. So 2p with a 3p square become 2 times negative 3 is negative 6, and p with a p square become p third, because p means p to the 1. So you end up with negative 6p 1 plus 2, so negative 6p to the third, which is this. And 2p times 4q, 2 times 4 is 8, apq. Okay. Now negative 3x with the x minus 2y. Because you have a minus inside of the parenthesis and there is something outside in parenthesis, you have to distribute this minus, distribute the second time, but you have to carry the sign. Okay, so that become negative 3x times x minus negative 3x times 2y. So you can put the parentheses in case you have a negative sign to show that's one group. So that end up with negative 3x squared minus negative 6xy. You have a minus with a negative, so that become addition with a positive, but you don't write a positive. So negative 3x squared plus 6xy become your final answer, like this. Okay. Now, when you have a binomial multiplied by monomial, just for the convenience, you can just switch them. Because if you have a times b, as long as they are multiplication, it's same as b times a. So the value doesn't change. So as long as they are multiplication, switching the order is allowed. So if you have a 2 times 7, which is 14, that should be same as 7 times 2, which is 14. So it is okay to change the order of each number or variable as long as they are multiplication. So just for the convenience, we're going to rewrite this one as a monomial times binomial, and then you distribute them. Minus this. So you have negative 3a times 2a. So let me rewrite this. Negative 3a times 2a minus 3. Then it becomes negative 3a with a parenthesis times 2a minus negative 3a times 3. I use this as operator. Then you have negative 3 times 2 with AA, which is negative 6a squared, minus negative 3 times 3a, which end up with negative 9a. So it become negative 6a squared minus negative become plus 9a. So you get the same answer. I did a little different way in here, but they are same. Okay. The way I did here was I changed 2a minus 3 as 2a plus negative 3. And then I distribute them. So a little different than here, but it's okay. How about monomial by polynomial? Again, you're going to, because you have plus and minus inside of the parentheses, you're going to distribute 4a with a 2a squared plus 4a with a 3a plus 4a with a 4. So when you do that, you get 4a times 2a squared, end up with 8a third, plus 4a times 3a, 12a squared, plus 4a times 4, 16a. Now, you have to be a little careful when you have negative numbers again with that. So you are distributing negative 3a times 2a squared. Again, I changed this time this as a 2b squared plus negative 3b. So negative 3a. So I'm distributing with this plus distributing with that. So you end up with negative 3. Sorry, it was b, right? Negative 3b times 2a squared plus negative 3b times negative 3b. You end up with negative 6b third plus positive 9b squared. That's how you do this. Again, you're distributing monomial times monomial, but again in here I also change minus to plus negative, so that 2c squared d squared with a 5c squared d squared plus negative 6c third d fourth. In this example, I changed minus into plus negative, and then I distributed it. That's how I did here and here when I distributed. Okay. Now, how about binomial times binomial? So we are done with the monomial. So now we are doing binomial multiplied by binomial. Sometimes we call this one as group distribution, since you have a binomial a plus 2 multiplied by a plus 3. So you can see that in this parenthesis, and this is a number in front of parenthesis, now this whole group is distributing it. So that becomes a plus 2 multiplied with a, and plus a plus 2 multiplied with a 3. So this whole group is distributing it. That's why they call group distribution. Again, when you do that, rewrite this as a with a plus 2 by writing monomial first, plus 3 with a plus 2. So when you do that, and I distribute them with a plus in between, a squared plus 2ab plus, when I distribute this with a plus in between, 3a plus 6. Oh, it was just 2 here, a plus 2, so it was just 2. So now a squared plus 2a plus 3a plus 6, 2a plus 3a become 5a plus 6. So that's how I got this answer. Okay. Now again, another example, a minus 2 as a group, and I'm distributing it. So I got this. It's only because in this particular one, I change a minus 2 with a plus negative 3. I mean, why did I do that? I don't know. But when I made this one, I particularly did this way. And then distribute this 2 and distribute with that. And you get this answer. Okay. Now, again, this one, this group multiply with that. So I'm distributing this with a plus distributing with that. And when you do this, you got this answer. Again, this group is distributing into this. Okay. Now, let me do this particular question in the other way, rather than changing into a plus negative 3. If I have a minus 2 with a minus 3, multiply them. This group is this, so it become a minus 2 with a minus this with that. So a minus 2 with a 3. So in this case, I use this minus as operator, so it's minus, and use 3 as a positive 3. So when I do rewrite this, a with a minus 2 minus 3 with a minus 2, I end up with redistributing. So a with a minus a with a 2 minus distributing 3 as this, 3 with a and minus 3 with a 2. I have to be careful here because since I use this one as an operator, here is a 3 as a positive 3. So I'm going to, but because you have a minus still, I have to be careful. So not to be confused, I put the parentheses there. So you end up with a squared minus 2a minus 3a minus 6. But again, I have to be careful on here because of the parentheses. Now I have to keep this change to on parentheses. That's why I changed from the beginning, because it gets a little complicated. So you end up with a squared minus 2a, change plus, and change everything inside, negative 3a plus 6. So now you have a like term here. So you end up with a squared plus negative 2a plus negative 3a plus 6. You end up with a squared plus negative 5a plus 6, which is plus negative means minus. So I got that the same answer. But it could be a little complicated. So before dealing with all this in grouping, I guess I change the a minus 3 into a plus negative 3, because when you're dealing with the plus operator, it's much easier. So instead of having 1, 2, 3, 4, 5, 6, 7, 8 steps, I finish with 3 steps here. So that's why I did that. Okay. But it's up to you. Whichever convenient for you, you do it. But be careful about sign-up operation. Okay. Now, this is by the distribution things. But there is something called FOIL method that many people like to do it. The FOIL came from F from the first, with the first one first. So when you have this, A and A first, because those are the first terms. And O to outside one. So A is outside on the left side, and 3 is outside on the right side. So you multiply them. And 2 inner one for I, 2 and A, 2 inside one, and L for the last one. So 2 times 3. So that we call this one is foiling it. Then what was the previous one? Previous one was a group. First 2 as a one group and distributing it. So how are they different? Well, when you have, again, when you have foiling it, F times A times A is A times A with the A times 3, 2 times of A, 2 times 3. That's what foiling is. The first one with the first one, outside one with the outside one, inside one is 2 with the inside one, and 2 and 3. So you end up with the A squared plus 3A plus 2A plus 6. 3A and 2A, you like terms. So that end up with A squared plus 5A plus 6, which is this. So now, if I foiling again. Example 1, x plus 2 multiplied with the x plus 5. If I foil it, x with x with a 5. So you are distributing actually first term with a 2 and second one with a parenthesis. And then x with x with a 5, 2 with x, inner one, last one, 2 with a 5. So that become x squared, 5x, 2x, 10. 5x and 2x have a like term, 7. So that's how you do that. Okay. Now again, x minus 1 times x minus 4. So if you have it, you get x with x times x with a negative 4, because you are distributing with x's. Now negative 3, because I made the x minus 3 as x plus negative 3. So negative 3 with the x and negative 3 with the negative 4. If you combine the like term, x with the x is x squared, x times negative 4 is negative 4x, negative 3 times x is negative 3x, negative 3 times negative 4 is positive 12. So you end up with this. Number 3, if I do it here, 2x minus 3 with 4x plus 5. Again, I'm changing this minus into plus negative, so that becomes 2x plus negative 3. Okay, so you multiply 2x with a 4x, and again 2x with 5, plus this time I'm going to use negative 3 instead of minus 3. Okay, so negative 3 with 4x, plus, you always plus from each term, negative 3 with 5. So you end up with a 8x squared plus 10x plus negative 12x plus negative 15. Now you have a 2 like term. So you end up with 8x squared plus negative 2x plus negative 15. But plus negative same as minus. Plus negative same as minus. So you end up with this, which is this. Again, 3x minus 4 multiplied with a 5x minus 6. I'm going to FOIL again, which means first term with a distribution and second term with a distribution. So 3x with a 5x, 3x with a negative 6, plus negative 4 with a 5x, negative 4 with a negative 6. So when you simplify them and combine them, you got negative 15x squared plus negative 18x and negative 20x, which are the like terms, and 24. Negative 18x plus negative 20x, addition rule, same sign, you add them, so negative 38x. So 15x squared plus negative 38x plus 4. Now I want you to try exercise and check the answer later. Now, there are a few things that it will help you if you memorizing kind of formulas. That's what is squaring binomial. So when you have a plus b square, okay, when you're squaring this binomial, always end up with a squared plus 2 times of a times b plus b squared. So it's like a formulas. So if you memorize the formula, you can get the answer faster. That's what is squaring binomial formulas. So whenever you have a plus b squared, it always ends up with first one square, second one square at the end, and 2 times of first one and second one. Okay? If you have a minus b square, then always come as a formula first one square, but minus 2 times of first one and second one, and plus second one square. So it's like a formulas. So this squaring example show you how to utilize the formula. Okay, but I'm gonna skip this for now. If you want, you can just try those. But more important, I mean, the other one is important as well, squaring the binomial. But more important one is this special product. Special product is when you happen to multiply a two same number, but one is plus and one is minus. When you have this, like a minus b, let's say plus first, and a minus b. As you see, a come out again, b come out again, but one is plus, one is minus. When you have this format, here comes another formula. This will be same as first one square minus second one square. So why do we need to memorize this formula? If you memorize this formula, you don't have to do all this like distribution things. You can just know it answer has to end up with this format, so you can get answer much faster. So that's why memorizing this squaring formula, or more importantly, special product formula, is become very important. Since this one come on your final a lot of times, let me just explain more detail. So when you had a plus 2 multiplied by a minus 2, so it only works for binomial multiplied by binomial, but they have a and a, 2 and 2. Okay, but one is plus and one is minus. Then always same as the first one plus minus second one square. First one square minus second one square. But what's first one? A. What is second one? Second term, 2. So if I simplify further, it's a square minus 4. A square minus 4. So you mean I don't have to FOIL this? No, I don't. It come out like this. Well, do you want me to show how to FOIL it? Yeah, I can show you. A plus 2, a minus 2, right? So a times a is a square. A times negative 2 is negative 2a. 2 times a, positive 2a. 2 times negative 2, minus 4. And always middle one cancel out because you have same coefficient. One is negative, one is positive. So you end up with a squared minus 4, which has the same answer as this formula. So it's not that difficult. So if you memorize this formula, only if you have this pattern, it's much easier if you memorize the formula and recognize it and use it. Okay? So, for example, again, number 2, b plus 5 times b minus 5. Again, same term. And another same second term. One is plus, one is minus. So you end up with b squared minus 5 squared, which is b squared minus 25. So you don't have to FOIL them, only if you have this pattern. Okay? Again, x plus y times x minus y become difference between first square and second square, which is a squared minus b squared. So you end up with that. Now, a little more complicated, but again, number 4, if you look at number 4, 2m plus 3b times 2m minus 3b. So that become first term as 2m and second term as 3b. So that become first term squared minus second term squared outside. So what is 2m squared? It's 4m squared. What is 3b squared? 9b squared. So you can get the answer very quickly if you have this particular format. Again, 3p minus 2q with a 3p plus 2q. Again, two same term. One is negative, one is positive. Then it becomes subtraction of first one square minus second one square, which end up with 9p squared minus 4q squared. Again, if you have a 2x plus 3y, multiply with a 2x minus 3y. First term is 2x. Second one is 3y. 2x squared is 4x squared after you simplify them, minus 3x squared become 9x squared in between. So this is special. So we call it special product. This become very important because later on we are using this property or formula for more advanced topic. That's why I'm spending time to express or explain this further. Okay. So do some exercise. Now, what if this is additional examples? What if you multiply like 3 groups? Then you can just do whichever you want. I'm going to do this first because I know x plus 2 multiplied by x minus 3 is a special product. Then I end up with x squared minus 4. And then I'm going to distribute them. So x times x squared minus x times 4. So I end up with x third minus 4x. Again, when you have x plus 2 multiplied by x plus 3 with x minus 3, I recognize this 2 as a special product. So I will do this first. So when I do that, I end up with x squared minus 9. And then you have a binomial with a binomial. So I'm going to FOIL them. FOIL. First one first. First one with the last one. Outside one. 2 inner one. 2 last one. That's how I'm going to multiply each other. So first one with the first one, and then with the x times x squared, and outside one plus x with a negative 9 plus 2 inside the 1, 2 with x squared, plus 2 with the last one, 2 last one, 2. I end up with the x third, negative 9, 2x squared, negative 18. Okay. So that becomes the answer. Again, this first two I recognize as a special product, so they end up with x squared minus 16. And I end up with x minus 5. This is binomial multiplied by binomial. So I'm going to FOIL them because it's easier to FOIL than group distribution. And you get this answer. Example number 4 and 5 are important because I saw these two questions a lot on the final. It's a binomial multiplied by trinomial, or binomial multiplied by polynomial. Again, when you have this, we do like a foiling it. First one, distribute. The first term of the first part, you distribute with all three of the second one. And then you add that with second one of the first one. And we'll distribute 3. So x with x squared, x with a negative 2x, x with a 3. And then you finish with the distributing with the first term x. Now 3 with this, 3 with that, and 3 with this. So x with x squared is x third. Plus x with a negative 2x is negative 2x squared. And x with a 3, 3x. And x with x squared, 3x squared. By the way, they are all addition in between. And now 3 with negative 2x with negative 6x. And last one, 3 with a 3 is 9. So if you rewrite this, it becomes that. And then you combine the like terms because you have x squared here, you have x squared there, they are like terms. So you group them. You have a x with the x, so you group them. And 9. So if you simplify the like term in group, you have x cubed and x squared minus 3x and 9. So that's how you do final answers. It looks complicated, but if you do step by step, it's not that bad. Okay. And now again, I'm gonna do this one here, x minus 2 multiply with the x squared minus 3x minus 4. Again, I'm going to distribute with x. So x with the x squared plus x with a negative 3x plus x with a negative 4. That's with the x. Now I'm going to distribute with a negative 2 with the x squared, negative 2, the negative 3x plus negative 2 with a negative 4. So I distribute with the second one. If you simplify, this one ends up with x third plus negative 3x plus negative 4x. Actually, it's a square here because you have 2 x's. Next one, I'm going to write under it negative 2x squared plus 6x plus 8. Because this is negative 2x squared. This is 6x. And that become 8. So you end up with x third, negative 3x with a negative 2x, negative 5x, negative 4x with a 6x is 2x plus 8. So this is another way of doing it for this particular question. Either way is fine. Okay. Again, only the practice make it perfect. You should try this many times. It's one of the hard questions. Now do some exercise. Check your answer with the answer key in exercise 1, exercise 2, exercise 3, and exercise 4. Okay. The last topic is division of polynomial, which is rather simple. There are two types of a division of polynomial. One is division of monomial by monomial. That means one term by one term. Another one is polynomial by monomial. That means you have a two term or three term, but always divided by one term. And others are polynomial, but we are not going to cover that in this particular video. So let's go back to monomial by monomial. So when you have a question like 6x fifth, which is monomial, divided by 2x third, what you do is you group them by like term or same base. So 6 and 2 numbers are like terms, and x fifth and x third are same base. Like we combine the same base in a multiplication and combine the numbers, you do the same thing with division of polynomials. And then you apply quotient rule if you have the same base. That's what we learned at the beginning of chapter 5. So that becomes 3, because 6 divided by 2 is 3. And because you have the same base, you subtract the exponents. So you end up with a 3x squared. Okay. So key was group them by same basis. Now, if you have a more complicated one, again, you group by 24 and 6, a fourth with a square divide, and b seventh by b third. And simplify 24 divided by 6 is 4. And division of same base, you use a quotient rule, which become a to the 4 minus 2 and b to the 7 minus 3. You end up with 4a squared b fourth, which is the same answer as this. So monomial divided by monomial is quite easy. You just separate them or group them. Do some exercise. Okay. Now, polynomial by monomial. So as you see in this rule, when you have a polynomial on the top and monomial by bottom denominator, all you have to do is you separate them. So you separate them and do individually. Okay, so 4x squared divided by 2 is 2x squared, plus 6 divided by 2 is 3. So when you have, like example 1, 6x squared plus 9 divided by 3, you break them. 6x squared divided by 3 plus 9 divided by 3. So you end up with 2x squared plus 3. Again, when you have 21b third minus 14b squared divided by 7b. By the way, this whole thing is one term. I hope you realize that, because when you have a long division sign like this, that makes it one group. So we call this one group term. When you have a one group term like this, you separate them. 21b third by 7b minus 14b squared over 7b. Notice that both of them has to be 7b, but you separate them. And then you combine them. So that become 21 over 7 as one group, b third divided by b as another group, 14 divided by 7 as one group, and b squared divided by b as another group. So 21 divided by 7 is 3. b third divided by b is quotient rule, b to the 3 minus 1, because when there is no power, it's always one power. And this is 2 with a b squared minus 1. By the way, it's minus. So you end up with a 3b squared minus 2b as a final answer. Okay. Again, when you have polynomial divided monomial, you separate them. Like this. And then you simplify, you get the answer. You separate this. And simplify the answer. Okay. So that's what division of polynomial by monomial type. So number 3 and number 4 is harder type, but that's important because I saw many times this kind of question on the final, so making sure you understand that. And please do the homework exercise, okay? And then check with the solution key, okay? Good luck for today. I will see you on next video. I hope you learned something today. But always practice and make it perfect. Practice, practice, practice. Okay, have a nice day. I will see you next video.